is on the sum and product of the roots. Hopefully this is working. Sum, of course, means to add. Product means to multiply. And what we're doing is we're adding and multiplying the roots of a quadratic equation, what we get when we solve it. So keep that in mind. The title of the lesson means a lot. So first we're going to look at some quadratics that we can factor to build our knowledge. X squared minus 7x plus 12 factors into x minus 3 times quantity x minus 4. And of course we'd split it, set them both equal to 0, and get that x equals 3. That's one root. And x equals 4. That's the other root. So let's just do a little practice now. Let's add the roots together. 3 plus 4 is 7. I want you to see that I'm physically adding 3 and 4. And let's multiply these roots together. 3 times 4 is 12. Now what we're going to recognize today is that in our original quadratic, we have clues to the sum and the product. I'll come back to that in just a moment. Second example, x squared minus 2x minus 3 factors beautifully, and we get the roots are 3 and negative 1. Summing those two roots together gives us 2, and multiplying those roots together gives us negative 3, of course. And the last example factors beautifully again. We split it, set this first factor equal to 0, we get 4/3. The second factor equal to 0, we would get that x is negative 2. So our roots are 4/3 and negative 2. We add those together. Let's see, I'm going to do 4/3, and I'm going to make negative 2 into negative 6/3. So that I get a nice easy fraction. And the product of those two roots, I can just multiply. I don't need a common denominator. Negative 8/3. So what I want you to see now, can you figure out how the sum of the roots, 7 and 2 and 2/3, appears in the quadratics that we started with? So examine these three quadratics and examine the sum. Here the sum is 7, so look at the quadratic. Here the sum was 2. In the second example, I see a 2 there. And in the third example, the sum is negative 2/3. Well, I see a 2 there. So I had a hypothesis, but it's not quite working. There's another difference in these quadratics. These two start with a 1, and this one starts with a 3. Any conclusions? I would conclude that that number divided by 1 is the opposite of the sum. This number divided by 1 is the opposite of the sum. And this number divided by 3 is the opposite of the sum. So I'm going to write a conclusion for you that the sum of the two roots is the opposite of B divided by A. That'll become clearer in a moment if you missed it. Let's take a look at the products. Here our product is 12. Look up at this quadratic and see if you see a 12 anywhere. Here our product is negative 3. Do you see a -3 anywhere in the quadratic? And here our product was -8/3. Do you see a -8/3 in that quadratic? Well, not directly, but this 12 matches the product. This -3 matches the product. And this -8 over this 3 matches the product. So our conclusion is the product of the roots is the last term divided by A, or is equal to C divided by A. That's actually going to work for every quadratic. So for every quadratic equation, ax squared plus bx plus c, the sum of the two roots will always be -b divided by a, and the product of the two roots will always be c divided by a. Let's write those as formulas. And these are formulas to memorize. S standing for the sum of the roots, P standing for the product of the roots. So let's build on that knowledge. Let's go back and actually solve a quadratic because I need to find the roots. We're going to find the roots, and then we're going to do the sum of those two roots, and then we're going to do the product. Now I can predict in advance by looking at my quadratic. I can predict the sum and the product. The sum should be -b over a, so it should equal -4 divided by 1. And the product should equal c over a, so it should equal 1 divided by 1. Well, let's see if this comes true. Let's see if that actually happens. Solving this quadratic equation, I'm going to use the quadratic formula. X equals -b plus or minus square root b squared minus 4 times a times c all over 2 times a. Let's go through and solve this quadratic. This is old stuff. So our roots are -2 plus the square root of 3 and -2 minus the square root of 3. There they are. So what's the connection today? The connection today is, what do I get if I add those roots together? What am I actually going to get? Well, that means we're going to do -2 plus the square root of 3, and we're going to add it to -2 minus the square root of 3. What do we get? -4. Lo and behold, it worked. Actually adding the roots gives us -4. Let's take those same roots and multiply them together. So this will be a little more work. Not too much more though. So multiplying my roots together means I'm finding the product of the roots. that's a subtraction there. So I have FOIL. Negative 2 times negative 2 plus 2 radical 3 minus 2 radical 3. Notice they're conjugates, so they're dropping out. Minus 3. Radical 3 times radical 3 is 3. So I get my product as 1. Lo and behold, that's what I thought it would be. Isn't this cool? It's totally cool. Totally cool. Let's do the next one. Solve the quadratic x squared plus 4x plus 29 equals 0. So you might want to pause. Go ahead and solve that quadratic. I'll give you a hint. There's an imaginary part to it. So here we are. Our roots are x equals negative 2 plus 5i and negative 2 minus 5i. Gorgeous. So let's keep those in sight, because now what I want to do with those, actually I can put them up here. We're now going to add them together. I think I can do it right here. Negative 2 plus 5i plus negative 2 minus 5i is negative 4 again. And I'm going to multiply those together. Negative 2 plus 5i times negative 2 minus 5i. We'll do all the work and then we'll see how it connects. I'm foiling conjugates. So negative 2 times negative 2 is positive 4. And we have drop out, and then we have 5i times negative 5i minus 25i squared. So that's 4 plus 25. Which is 29. So we've done all the work. We solved our quadratic. We found our roots. We added our roots, and we multiplied our roots. Now make the connection. Did we expect the sum of the roots to be negative 4? Is this equal to negative b divided by a? A is 1. B is 4, C is 29. We sure did. Negative 4 it is. The product of our roots is 29. Did we expect the product of our roots to be 29? Well, the product of the roots should be C over A. 29 divided by 1. Yep, 29 it is. Sum and product of the roots. Let's keep going. So these examples now give us different information. For the examples below, one root is given. Find the other root. So in the first example, negative 5 is given. I need to find the other root. In the second example, 1 is given. Find the other root. And in the third example, 1 is given, find the other root. So what in the world are we going to do? We have the quadratic and 1 root. Now you have to be a detective. The only pieces of information I have are 15 and 1. The product part is missing. So what I do know here is that the sum of my roots, if it's going to be negative b over a, is that the sum of my roots should be negative 15. So now I know if I added these two up, let's just call that r. If I add negative 5 plus r, I should get negative 15. That means r is negative 10. Just solve that equation. Let's try the next one. What information do we have in the quadratic? C is missing again. I have A and I have B. So I have to work with the sum. The sum of the roots would be negative 3 over 2. So let's call that second root r. And we know if we added those two roots together, we should get negative 3 over 2. I'm going to subtract 1, which is the same as subtracting 2 over 2. And I have my other root would be negative 5 over 2. And don't forget what we're finding. We are finding where these parabolas cross the x-axis. These are the roots. As long as they are real roots, they cross the x-axis. All right, third example. If you want to give it a try on your own, go ahead and pause the video. I'm looking for a second root. What clues do I have in the quadratic? I've got that A is 1, B is useless to me, and I've got C is 3. So I have to work with the product this time. And the product of my roots is C over A, so 3 divided by 1 is 3. So I know if I multiply my two roots, 1 times r should give me 3. Well, that's simple. R is 3. And there we go. The other root is 3. Cool. What does the next part give me? If 1 root is given, find the quadratic. Nope, find C. Sorry. If 1 root is given with the quadratic, find the other root. Good, we know how to do that. And find C. Okay, so we know we're going to be looking for the other root. I don't really need that part. That's okay. 1 root is that, and we're looking for the other root. Good. And we'll use our quadratics for clues. A is 1, B is negative 8, and I don't know C. So we're working with the sum. Negative b over a will be negative of negative 8 over 1. The sum of my roots is 8. Negative 5 plus r should be 8. So that makes r 13. They wanted us to do one more step. If 1 root is given, find the other root and find C. So C here would be part of the product of the roots, especially since A is 1. So the product of our two roots is negative 5 times 13. That's negative 65. So the value of C, because it's all alone in this part, is negative 65. Or C over 1 is negative 65, which makes C negative 65. Next example. find the other root. We've got a 1 and a -4. So again, we're working with the sum. So the sum is 4. One root is 1. The other root added to it should give us 4. And so that other root is, if you said 3, you are right. So we'll put that right up there. And then we want the value of c again, which again is just going to be the product. The product of the roots would be c over a, but a is 1. So the product of our roots is the value of c, and we have 1 times 3, which of course is 3. Okay. How are you doing so far? Last part. Here we're going to build the quadratic. I don't know the quadratic equations that these go with, but we're going to figure them out. So in this case, both roots are given. You can see that in the first example. Both roots are given. We're going to figure out the quadratic. So I know when I write a quadratic, that in front of x, as long as a is 1, in front of x is the opposite of the sum. And my constant term at the end of my quadratic is equal to the product. And we're talking about the sum of the roots, sum of the two roots, and we're talking about equal to the product of the two roots. So let's see what we have. If our two roots are -5 and +2, then they add up to -3. And they multiply to -10. Now these numbers are going to go into my quadratic. My quadratic will be x squared. And then we want, pay attention because it's the opposite of the sum next. Whoops. Opposite of the sum goes there. So if the sum was -3, we have +3x. And then in the last slot, the product of the two roots, which is -10. And we're making equations, so don't forget your equal sign. So again, opposite of the sum goes right there. The actual product goes right there. Okay? Let's try a couple more, and then I'd like you to try some on your own. Really pause the video. Let's take our two roots, 1 and 8, and what do you get when you add them? 1 and 8. What do you get when you multiply them? Let's write the quadratic. X squared plus the opposite of the sum. Sum is 9. So we're going to write -9x plus the product, the actual product is +8 equals 0. Okay, let me do that in green. 8 and 8. 9 and -9. Right? Okay, radical roots. So what do we get when we add 1 plus the square root of 7 plus 1 minus the square root of 7? It's easier than it looks. Those drop out, and we get 2. Product of those roots, FOIL. 1 times 1, drop out, minus 7. I'm foiling two conjugates, so they're going to be dropouts. Negative 6. All right, we have a 2, and we have a negative 6. What does that quadratic look like? Did you get it right? Hope so. 3 minus I and 3 plus I. Sum of these two is 6. Product is 3 times 3 is 9. Dropout. Minus I squared is 9 minus negative 1, also known as 10. What's the quadratic? We have a 6 here. We have a 10 here. So we have a negative 6 here and a 10 here. And we are good. Last one has a scary fraction in it. Let's add 1/3 plus 2 is equal to 6/3. So I get 7/3, our first fractional value. And the product, 1/3 times 2, let's put that over 1, is actually 2/3. So I'm going to put the opposite of 7/3 and the actual value 2/3. Let's see what this turns into and what you think I should do next. Because we don't have quadratics that have fractions as our coefficients. They're always integers. So what could I do to this quadratic to fix it up? Make our coefficients integers. If you said multiply through by 3/1, you are in great shape. 3 times x squared, 3 times 7/3 x. We can throw our 3's in here if you want. Those are going to cancel. And 3 times 2/3, and 3 times 0. And there's our quadratic. Looking good. So we can go on here. There is another page with extra practice for the sum and the product of the roots. This is great practice. I'm going to keep going and fill these in. I would recommend you pause your video here and you check these answers after you're done. That way, it's going to look like the video's long, but it's really not. So, I'm going to keep going here. You pause and check. All right, kiddos. Hope you checked these. If you have any questions, let us know tomorrow. Happy to answer anything on sum and product. The next page in your notes is a pretty challenging page. If you can do that, you truly understand sum and product. Have a great night. See you tomorrow.